Hey guys, Mr. Riz here to help you out on the kind of real first day of ellipses. I know we went through a day and did the interactive websites to kind of familiarize ourselves with what an ellipse is and how does it work. How does the formula kind of look like? But today we're going to jump right into it. So what we need to know is some things about the ellipse today. So an ellipse is a set of points on plane P such that the sum of the distance from P to two fixed points, F1 and F2, those are the foci, is constant. So the distance, this F1 might be shorter, it could be longer, or they could be the same right in the middle, or we can make F1 longer, make F2 shorter, but the distance collectively between these two things are always going to be the same. Those fixed points we said are called foci, or basically each one is a focus. The major axis is a segment that passes through the foci and the endpoints of the ellipse. Okay, those endpoints of the major axis are called vertexes. So wherever the foci are at, the vertex are there. It's also the longer side or the longer part. The minor axis is a segment perpendicular to the major axis, so it splits it right through the center of that. The endpoints of the minor axis are called co-vertices. So the co-vertices are like the opposite ends. If we kind of think of like a diameter of a circle, the big part here is the vertex and the small part is the co-vertex. All right, the center of the ellipse is just the midpoint between those two major and minor axes. So the one thing to note here is that we can have an oval that's flat and skinny, or yeah, flat and wide, or tall and skinny. And so that determines whether, is this like an x-axis or a y-axis equation. Um, and if it is, we have a couple different formulas we will use to find those things. So we'll use this formula chart to kind of go back and forth to find some things. We won't get too crazy about talking the eccentricity of it or the chord focal length, but we're going to go through and do some very basic things. Okay, so the first thing that we're going to do today is making sure we can write the equation given the vertices and the co-vertices. So we have an equation here. We have the vertices are at 6, -8, and 6, 4, and the co-vertices are at 3, -2, and 9, -2. All right, so look at the vertices. Do you guys see anything? All right, so if we look at the vertices here, on the first one, the x's don't change. And then the y's don't change on that one there. And so if we're actually looking just specifically at the vertices, what we need to do here is to just kind of look here. We already know this would be the longer axis here. If the axes don't change on the vertices, look up at the top here. All right, if this was the vertices, does this x change compared to that x change? Yeah, it does. The y doesn't change. So looking at these vertices, if the x doesn't change, this would be a y-axis ellipse. Meaning it is a tall, skinny ellipse, okay? So what we need to do is to find the center of the ellipse. Well, the nice thing about the center is that we can use midpoint between either the, either the vertices or the co-vertices. We'll get the same answer. And just to kind of prove this, what's the midpoint between 6 plus 6 divided by 2 and then -8 plus 4 divided by 2? Okay, that would be at 6 plus 6 is 12. 12 divided by 2 is 6. And then -8 plus 4, that's -4. -4 divided by 2 is -2. You guys want to see an easier way we can do this? What number do the x's have in common? 6. What number do the y's have in common? -2. 6, -2. All right. What is the length of the major axis? The distance between the two vertices. Okay, so what we want to do here is to look at the major axis, which we know is at 6, -8, which is down here, and 6, 4 up here. All right, so what's the distance between them? Well, all we need to do is look to see what's the distance between -8 and 4, or going from 4 to -8. That would be a distance length of 12. Okay, next what we need to do here is to find the length of the minor axis, the distance between the co-vertices. All right, so the distance between the co-vertices, we got what point at 3, -2, be right here, and 9, -2. All right, what's the distance between that? That is a distance of 3. Okay, so now what we need to do is come to the equation. Oh, you know what? Got rid of all that. Okay. It's all right. We know that the center was at, what, 6, -2? I was trying to scroll down and I just got rid of everything. It's okay. All right. Is that 6, -2? And this is a y-axis. And the length was 12. I believe this was 6. Yeah, okay. All right. What is the equation? So the equation we would start out with y equals, or actually we could put the x equals here first. It actually doesn't matter what order you put them in, but it matters what number is underneath. Remember, all ellipse equations end up with equals 1. 1 second here, I got to pause. Okay, so what we have here is to look at, let's talk about the major axis. The major axis, if we remember, is 12 units long. What we actually want to do is look at what's called the semi-major axis. So if this is 12 units long, that is 6. So remember, that is our y-axis here. And so our b value, or actually our a value, the number underneath the y is going to be 6 squared, which is 36. And if we look here, if it is the minor axis is 6 long, meaning it should be 3 by 3, our number underneath the x would be 3 squared, which would be 9. Okay, the only other thing we need to do is to put our center. The center is located at HK. So I kind of like using this formula here a little bit better because H is 6, K is -2, so we'll make this a +2. If you use this formula here, you could get the exact same answer. It would just be y plus 2 squared over 36 plus x minus 6 squared over 9 equals 1. Same answer, same thing. It's just, you know, we switched this group around with that group. Okay, so let's try this again one more time. So the first goal is to make sure we can get the equation given the vertices and the co-vertices of the graph. All right, so let's look at this one here. In this problem here, we got x is -2, -6, -2, -4. So okay, so this ellipse here, the x does not change at all. So once again, this is another y-axis ellipse. Okay. The co-vertices, and maybe, take a second graph. We got -2, -6, we got -2, 4, and then we got -5, -1, and then +1, -1. Okay, so let's go through. Find the center. We can cheat here. What do they have in common? They have a -2 and then a -1. So -2, -1. Or we could use midpoint if you want. But that's where the center would be at, -2, -1. What's the length of the major axis? The major axis, the distance between -6 and 4, that'd be a distance of 10, meaning we would have 5 and 5 on each side. What's the length of the minor axis? The distance between the co-vertices. So -5 to +1 is a distance of 6, so it'd be 3 and 3. Okay, so let's write this up here. All right, if we're going to use this formula here, we are going to start out with y equals because it's a y-axis equation. But I always like to do x minus h squared plus y minus k squared equals 1. All right, so let's talk about this. What is our h and k? Our h is -2, so we'll make an x plus 2. And our k is -1, so we'll make an y plus 1. And then let's look, what is the length on the y? Up and down on the y, we got 5, so we'll put 5 squared, which is 25 underneath the y. And what about the x going left and right? It's 3, 3 squared is 9. So there's our equation. We can always kind of double check these things out by typing that problem into Desmos. And let's go ahead and do that here. +2 + 1, 9, 25. Okay, I think I can memorize that. So go ahead, open up Desmos here. So Desmos, once again, in this whole section is going to be our helper. So we got x plus 2 squared, and then we got to divide this whole thing by, oh, I already forgot, is that 9? And then plus, that's not a plus, plus y plus 1 squared, and we got to divide that whole thing by 25, and then equals 1. All right, if we click on our graph, we can actually see, oh, it says it's undefined here because, yeah, it actually makes it, but that's actually, it should come out as a point, but we can actually kind of see on a graph that would be right here at 1, -1, and 5, -1. I wonder why that's coming out as undefined. It shouldn't, but that's kind of weird. Good enough there. Okay, guys, so there's what we're going to do first is just make sure we can understand this. If you guys have any questions, feel free to ask, but we're going to start kind of slow on this section, make sure we understand this part. All right, guys, have a great day, and I'll see you next time.